Okay. I see most students have done. I just made a huge mistake. I didn't start the recording. So later on, I will do a 30-hour video myself, maybe a little shorter. Anyway, can you remind me, please, if I didn't do it? Can you let me know? Now, just now, Mavis wanted to inform me, but I didn't see her message. This is the answer, girls. I just wrote the answer. I didn't write all the steps. But I know that to get the final answer, you need two differentiation. You need to differentiate the outside function and differentiate the inside function and put them together. However, whenever you see an opportunity to simplify, even if just a little bit, you should do so. As you can see in this function, I took out 6, right? And in the second function, I eliminate this fraction. You practice and you will get better, okay? Now let's go back to the first page. Now, I hope now you can understand this comic better, because this is a pregnant lady, and to ddx this function, that is to differentiate the mother, leave the baby inside and differentiate the baby. I don't know if this makes sense. If it doesn't make sense now, I think later on, as you practice, you understand this more. Later on, you will understand this more, but you need to practice it. The first page also, we have a large space for the proof of this. Now, I think the proof of this is just like it's a process to go through. It's not like you see the result is so difficult to believe already. Should I say difficult to believe or easy to believe? I think it's the I think the proof itself, the proof of this theorem, this rule itself, it's not very fascinating though. You will see it's very plain. It's bland because you're just, you will see. You will see. Let's see the proof. dy dx. Of course, we're using first principle. You see, it's bland. So like you follow this and follow this, you get it. I think the outcome is very interesting. The outcome is more interesting than the proof. Maybe for you, it's always the case, is it? Now here, in order to, I don't know if this makes sense. Does that make sense? I'm not adding and subtracting. I am dividing and then multiplying. Okay. And then I'm writing two limits, but the first one, this one I will write, instead of writing u, I will write u plus delta u minus gu divided by delta u. Does that make sense? A little bit, because h is u, right? And this one, instead of writing h approaches to 0, I write delta u approaches to 0. And this one, I'll write another limit. Okay. So this one will be g prime with respect to u, and this one will be h prime with respect to x. If I write the other notation, it will be dy du times du dx. I don't know. So that's what it is. I think the proof doesn't make you feel more safe with it. Should I say that? It looks like I already know the answer. I'm just working my way toward the answer. I think in a way it is. In a way it is. This proof is very simplified. It's like, oh, so easy. How do you know to do this? It's like I know the result, and I try to show you why it works. But the rule itself is quite fascinating. And also, now to memorize this rule, some students suggest looking at it like a fraction, like dy over du and du over dx. I never said over, remember? During these weeks, did I ever say dy over dx? I never say that. I just say dy dx. Because I don't see it as a function, as a fraction, because I see it as a function. So it's a derivative function. But if you see it out, because looks like a fraction, right? If it looks like a fraction, then you see the du and du can cancel each other out. Maybe it is equal. I think that some teachers also use this way to trick the students into believing this rule. Now, I welcome all different kinds of doubts. If you have any interesting ideas, you can ask. If you don't believe they're equal, I will discuss with you and find a way to make you feel this is natural. Because every day when I give the lesson, I have to choose so many ways. I have to choose one way I think is the best fit, but it's not the best fit for everyone. It's not. If you cannot understand, let me know. By understand, I mean feel this is normal. Okay. Next page. Now, starting from example 12, I'm going to speed up. By speeding up, what do I mean? I mean, I don't show you the u part, and I just know what's u in my head, and this takes practice. You listen to me. Now, I know in my mind, I know y is uq. U is this fraction. Okay, I know that. So dy dx is first, it's like I blur this out. I will see something cube. So I will have 3 something squared. And then I will differentiate this. Now this time I will write, I don't write the prime notation anymore. I will write ddx. Okay. Now I have the first one, that is the first differential dy du, and then d dx. Now I don't write du dx. This is u already. So it's du dx now. And this is 3x plus 4, 2x minus 5. Okay. And then 3x plus 4, 2x plus 5 squared. And this, this is a normal differentiation, although difficult. D high, low. I'm also speeding up with the quotient rule. Minus D low, high, divided by low squared. Okay. After 2 lines, I have no differentiation. I just need to simplify. Sometimes it takes even longer. This is 6x minus 6x, the negative 15 minus 8, negative 23. Okay. So together it's negative 69, 3x plus 4 squared divided by 2x minus 5 to the power 4. That's the answer. You try, and you raise your hand when you're done. Turn your cameras. Okay. You stop now. You listen to me. Now the differentiation of this function should be done like this. You know this is u to the power 1 over 2. So you write dy dx is 1 over 2 u negative 1 over 2. Whatever it's inside, just write it in. And then ddx, the next one, du dx. And then you differentiate. Now with the simplification part, you see this is what I do with the negative index. I will leave the answer this way. I will leave the answer this with a negative index. Sorry, I need to look at the message. Is the answer 5 over 2? 5? Why is it? Oh, 3 over 2, I mean, sorry. 3 over, Yes, 3 over 2, sorry. Made a mistake here, 3 over 2. Anyway, now when you are simplifying, now this I would not consider the final answer, girls. Here. Because there is 4x plus 1 and 4x plus 1, the two factors should be put together as a single factor with the power. But I did it wrongly. I did it wrong. Anyway, you work out the index and then you put your final answer in the index form. The negative index is fine. If you prefer the positive index, that's fine as well. Positive index, that's fine, but you will write a fraction. But I do not recommend the third form. Please don't write the third form. Most of the time, you don't need to write the third form, unless the third form is easier. Next question. Now this is getting harder. This is getting harder. This is a product, but one of the factor is composite. 8 ddx 6x minus 5 cubed 2x squared minus 7 is ddx this times 2x squared minus 7 plus 6x minus 5 cubed ddx, the second one. Now the power rule still works. The power rule still works. You can still use the power. But inside the power rule, you have a composite differentiation. So this will be 3u squared. And then ddx 6x minus 5 times 2x squared minus 7. And this one is 6x minus 5 cubed. And then times 4x. Okay. And then still haven't done. 6x minus 5 squared. This one is 6, 2x squared minus 7 plus 4x, 6x minus 5 cubed. Okay, now the differentiation is done. Right now, do you leave the answer like that? No, you need to simplify. I know. Now, how to simplify? Do not expand. Okay, do not expand. Look for the coefficient, look for the factors. Take out the common factor. In this case, I'm taking out 6x minus 5 squared. I'm left with 3 times 3, 2x squared minus 7 plus 2x, 6x minus 5. Okay, and then you will simplify each factor. This one is 9, that's 18x squared. And this one is 12 squared. And then 30x squared minus 10x minus 63. And then you're done. Okay, unless this can be factorized again, I don't think so. I don't think so. But you can use the formula to check. Okay. Part B. Part B. D dx 2x minus 7 4x minus 5 is equal. I think I'll just use the product rule, okay? 2, and then multiply the second one, plus copy the first one, and d dx the second one. Okay, now inside the differentiation, the second differentiation is a composite one, although you don't think so. You may not, oh, this is composite, this looks so simple. It looks simple, but it's composite. One over 2 u to the power negative 1 over 2 and du dx. Okay, 2 4x minus 5. Now, while I'm doing, I'm just going to see if I can simplify anywhere. Okay, this is 2x minus 7, and then this is 1 over 2. This is 4x minus 5, negative 1 over 2, and this is 4. Okay, like this. Now, with this simplification, I don't think you can expand here. It's not over, guys. I know the differentiation part is done, but the simplification is not over. You need to learn how to simplify. Okay, you watch. This is even more difficult here. Now with this with this function, to simplify, I suggest you take out a common factor, which is 2, and another one is 4x minus 5 to the power negative 1 over 2. Okay, you take out this common factor. Now, what do you have left? You will have 4x minus 5 left in the first term. Now you may, oh, why is it 4x minus 5? You see, this one is 1 over 2, right? This one is 4x minus 5 to the power 1 over 2. If I take out negative 1 over 2, this will become 1. This power will become 1. Think about it. This is 1 over 2. I take out negative 1 over 2. The power is left. The power left is 1. So this is 4x minus 5. That's it. Now the second one is 2x minus 7. Okay, and so it's 4x minus 5 to the power this, and then 6x minus 12, right? And then I will even take out 6 out, 12, 4x minus 5 to the power negative 1 over 2, x minus 2. And then I'm done. Okay. Now in this part, I think that you both learn how to do the differentiation and the simplification. You do the classwork now. The classwork is more difficult because it's a product and each factor is composite. I'm also going to check your simplification and see if it's okay. Raise your hands when you're done. Okay. Now, Bai Ling, Christy, and Cindy, you need to be faster. Okay. You work on it. Okay. I know it's not easy though. Now look at my answer. Now your answer may not be so long because maybe you would not write the first two lines like I did. I showed the power rule. Now in my answer, I show the power rule. Oh, sorry, not power rule. I showed the product rule. Product rule, yes, product rule. And then I showed the chain rule. Do you see the chain rule? This is a chain rule. This is also a chain rule. This is the first differentiation. This is the second differentiation. I use multiplication. Now you might, when you do it, some of you are very fast, so you can do it directly. That's fine. That's fine. This is the result. So this line is after differentiation, basically. Okay. And then simplification. Like I said, you do not expand and you do not leave it there. You don't leave it there. You take out the factors. Okay, you take out the factors. The highest common factor in this one, because we don't have thirds anymore, that's easier. Still, I think the difficulty level, if you use it S2 students factorization questions, nowhere near this difficult. You take out 4, this 9, and this to the power 10, and then what's left? And you must check very, very closely what's left. Now what's left is 15x, 4x plus 3, and 11x, 3x squared minus 2. That's what's left. And inside this huge bracket, this is the largest factor, and then you need to simplify this factor as well. And later on, use formula 01 to check if this one can be factorized. If it can be, you need to factorize again. Okay? So that is how you do it. Okay, next one, next page. This one is a composite inside another composite. Let me just show you why. Let me just show you why. This one, I think this one is the hardest now in our textbook. But anyway, our textbook, like the exercise goes way far further than the example. dy dx is equal to, first, the chain rule. 3 something squared, and then d dx something. That's my chain rule. Now, I would not write this out because it takes too much time. Later on, I will fill it in. Later on, I will. But I know what's inside. This is 3u squared and then du dx. I know what's in it. And then this is 3u squared. This is 3 minus d dx this. Now, what do I mean by chain rule inside composite function inside composite function? You see the outside one is a composite function, but here inside the differentiation, this part is also, sorry, 1/2. Now, this part is another composite function. So it has layers, you see, it has layers. And this time it's 3u squared and then 3 minus that. This is not u now, this is 1/2 w, negative 1/2, and then dx this. You know what I mean? Now I fill in. I will fill in this one. This one is 3x minus this. This one is 3x minus this. This one is 3x minus this. And this one is x squared minus 5. Okay, there's another chain rule here, you see. And then now I'm done with differentiation. Oh, I'm not done. One more step, I'm done. Minus this. Wow. Then 3 minus 1/2 x squared minus 5, negative 1/2. And this one is 2x. Okay, and then I'm done. There is no ddx anymore. I'm done. Now I simplify. This one is just x. If you allow me, I will do this. Now, sometimes I do this just to see if there is anything I can delete. Now, sometimes I write this form because I want to check if there is anything here. Because this will be a fraction and this will there, you know, sometimes there is something here to cancel this out, maybe. Sometimes I write this way. But in this case, I don't think so. I don't think so. I will leave my answer like this. Okay. Now, oh, sorry, this is not the answer. dy dx. X equals 3. 3 times 9 minus √4 squared. 3 minus 3/√4. This is 3 times 49 and 3/2. So it's 49 times 9. 441 divided by 2. The answer. So I guess the simplification here is not so important then. But anyway, you need to try to be as simple as possible when you do the differentiation. Now you try. The classwork. You try the classwork. And more classwork. The next page is more classwork. Now try this one, and when you're done, raise your hand. Only this one. Only this one. And later on, we'll have a time that you will practice the rest. Huh? Sorry. Wow, why is that? Yes, I was speaking. Just now I was speaking. I was commenting on how complicated this is and also responded to Bailing's comment that this cannot be done in one line. You must be prepared to turn another page even with the simplification. The final answer for this question, I think it's 7. After substitution, I think it's 7. That's okay. That's okay. Now, because the last question is the hardest, it's a chain rule inside something else, and then another chain rule. So I gave you 4 more classwork to do. Okay, give you 4 more classwork to do. If you're done, you check your answer with me. I'm not going to pause my screen this time, okay? If you're done, you check the answer with me. Now, when you're done, you let me know by raising your hand. If you're done, then you need to check if your answer is the same or even simpler than mine. Okay. Now you need to stop now. Stop. Stop. Now let's look at the answers. Now this time I didn't write so many steps. Technically, you don't have to write so many steps. It can be done. It can be done in one go. The differentiation part can be done in one go. Now, this is the product rule, and in the chain rule part, that is the thing sometimes you forget. It's the du dx. As the simplification, this one is even harder than before. This time, I will take out the fraction and the common factor. Now, the fraction and the common factor. So here there's a 2, and then this power that you think, why is this? Why is the answer this? I know we've never done factorization this way. I take out a negative index, and then you put in a positive index inside. And also you take out a fraction, and then you put in 2. You take out 1/2 and you put in 2. Okay. Now the second question has a lot of surds. Now, this is the chain rule for the first time, and then chain rule for the second time. And sometimes you may forget this part. I think most students will remember this part. The first chain rule, everybody will remember, but the second chain rule, this one. And also when you simplify, this is just unusual. Normally a lot of students will stop here, but if you simplify the inside a little bit more, you will find out a factor that is identical to the outside this factor, and then you put them together. That's why in my final answer, you don't see the negative 1/2 anymore. You see 1/2. Do you see? The negative 1/2 is gone. Moving on. Next one. In this one is the quotient first. So quotient rule first, and then the chain rule. Now this time, although you're doing chain rule, but the second du dx, this part, turned out to be 1. So it doesn't change the fact that doesn't change the result. I mean, but it doesn't mean you don't do it. You still have to like intentionally put down du dx to remind yourself you've done the chain rule here, and then the simplifying. Now the simplifying here is also difficult because I took out 1/2. I also took out a negative index, just like part A. And then I put in 2 and then a positive index there. You see my final answer. You see this, the fraction becomes 3/2, right? And then 2 is put here. It's very strange. It's very strange how the answer is like that. But you must try your best to simplify. Because later on, when you're doing chapter 6, you will know that simplification is very, very important. Otherwise, you cannot solve any equation, or you have to simplify to solve equation. Last question. The last question is much easier. It's just like the example. Only the last part, this part. A lot of students asked me before, in the past years, they asked me, Ms. Chen, do we have to simplify this factor? Technically, this factor is not simplified, but you don't have to do it anymore because the expansion will be too much. Okay? So you stop there. Just because we want the answer to be short. Any questions? So that's the chain rule. That's the chain rule. I think next time we will finish 2 sections, 5.3, 5.4, 5.5, at least. And the new test dates has been posted. Please go check. That's all. That's all. Today, let's end earlier. If you don't have any question, you can go. Bye-bye.
Bye, Ms. Chen.
Yeah. Huh?
I'm sorry, Miss Chen. I think Emily has left, but may I ask, is it possible for you to postpone the test for a week? Because I think that week we have
Which test for a week?
the core test for a week.
The core test is the 5th of November now.
I think it's the 2nd of November.
2nd of November. That's next week, right?
Because I think that week we have econ and Chinese common test.
2nd. You mean 9th?
Yes, can you postpone it to the 9th of November?
But are we doing? Maybe. But then we have to do the other. Wow, that's very tight.
Okay. Thank you, Ms. Chen.
But anyway, we will try. We will try.
Thank
But
you.
maybe we will try to. I think the Saturday's lessons may not be enough because we still have 1 more chapters to go. So maybe we will do chapter 6 in school in November, I think, after the locus is done.
Okay, thank you, Ms. Chen.
Okay.
Bye-bye.
Bye-bye.